Good morning, dear students. How are you? Hope you all are fine by the grace of Almighty Allah. So, dear students of Standard 9, welcome back to my physics class. Dear students, today I want to finish your chapter 7, that is sound. And today I will explain some topics from this chapter. Those are variation of sound, actually to be sound velocity, musical sound, and sound pollution. At first, variation of velocity of sound. In air, velocity of sound is proportional to the square root of the temperature. That means velocity is proportional to square root of temperature. So if temperature increases, velocity also will be increases and will be increased. And if temperature decreases, velocity decreases. So here that temperature cannot be calculated in the Celsius scale. Rather, it will be calculated in the Kelvin scale. The velocity of sound doesn't depend on the amount of air pressure, but it depends on the density of air, and the velocity of sound is inversely proportional to the square root of the density of air. So, if water vapor increases in the air, that means density decreases, hence velocity increases. Sound is a mechanical wave. It depends on the elasticity of the medium. The nature of liquid and solid is different from air, and naturally the velocity of sound is different there. In liquid, the velocity of sound is more than that of the air, than that in air, and in solid, velocity of sound is even more than in liquid. So the velocity of sound is highest in the solid medium and it is least in the air medium. Look here, there is a chart and that showing the velocity of sound is different in different medium. You will require this chart to remember for solving MCQ questions. Now there is a mathematical problem for you. At a certain place, the temperature in the water is 10 degrees Celsius and velocity of sound is 332 meters per second. If the temperature is raised to 30 degrees Celsius in the summer, what is the velocity of sound? So we know from the previous discussion, V is proportional to square root of T. So we can write V1 is proportional to square root of T1 and V2 is proportional to square root of T2. So by dividing V1 by V2, we can get V1 by V2 equal to square root of T1 by T2. So from here, we have to find out the value of V2 because V1, that is the velocity of sound in temperature T1 and T2 is the temperature, in which temperature you will find out the velocity of sound. So V2 equal to V1 divided by root over T1 by T2. So we can write V1 into T2 divided by root over T1. Here V1 equal to 332 and T2 equal to 30 degrees Celsius. So I have already told you that temperature should be calculated in the Kelvin scale. So in order to calculate Kelvin scale, we have to add 273 with 30. So 273 plus 30 divided by 273 plus 10 meter per second. Then finally the result comes 343.5 meter per second. There is another mathematical problem. Sound of frequency 1 kHz is produced by a tuning fork. It was allowed to pass through air, water and iron. It was found that the velocity of sound in air is 334 meter per second, in water 1493 meter per second and in iron 5130 meter per second. What are the wavelengths in these mediums? So you know velocity of sound V equal to f lambda. Here lambda is the wavelength and f is the frequency. And the sound which is produced from the same source is allowed to pass in three different medium, that is air, water and solid medium, and we have to find out the wavelength of sound in these three different medium. where the frequency remains constant, that is 1000 kilohertz, so 1 kilohertz or 1000 hertz. So V equal to F lambda, so we can write lambda equal to V by F. Okay, and in different medium we have to find out the wavelength of the sound. So in air, lambda equal to V by F, but in air medium V is what? 334 meter per second, and frequency is same, so it becomes 0.3 meter. In water, similarly lambda equal to V by F, here V equal to 1493 and frequency remains same, that is 10 cube, and it becomes 1.49 meter. In iron, lambda equal to V by F, V equal to 5130 divided by 10 to the power 3, 10 cube, and it becomes 5.13 meter. Have you understood the math? Now I will explain musical sound. Graphical representations of sound waves. Musical instruments do not produce pure tones. The waveform is still distinguishable in this recorder sound wave pattern. The sound wave pattern of tuning fork, then flute, and then violin are shown in the figure graphically. And this type of figure is also given in your book, and you have to try to memorize, try to remember those patterns, because in MCQ these may come. So now we will understand different musical sound, different term related to musical sound: intensity, then pitch and timbre. Intensity. These are the characteristics of sound. Intensity is a measure of how loudly a musical sound can be heard. Therefore, the amount of sound energy that flows per second per unit area is called intensity. The unit of intensity is watt per meter square. Watt is the unit of sound energy and square meter is the unit of area. So here the amount of sound energy that flows per second per unit area is called intensity of sound. Pitch, the characteristic of musical sound by which the sound of the same intensity is sometimes heard dull and sometimes sharp, is called pitch. Timbre, the characteristics of sound by which we can differentiate the sound produced from different musical instruments is called timbre or quality of sound. So now let's know these three categories elaborately. Look here, you have learned about intensity of sound, that is sound energy that flows per second per unit area is called intensity of sound. So look, here it is low intensity sound and here it is high intensity sound, because more sound energy passes through the unit area per second. That means in 1 second more sound energy is passing through the unit area by this source. So here it is high intensity sound and it is low intensity sound. Now learn about pitch. Pitch of a sound is judged in relation to other sound. It refers to whether it is high like the sound of violin or low like the sound of a bass. Pitch and frequency are directly related. The higher the frequency, the higher the pitch, and vice versa. That means the more the frequency of a sound, the more pitch will be there in that sound, and vice versa. Now learn about timbre. What is timbre? In music, timbre that is pronounced as timbre, describes the quality or character of a sound or voice. Timbre helps your ears distinguish one type of sound production from another. For example, the sound of your cat from your dog, because the sound of your cat is not similar to the sound of your dog, so we can differentiate these two sounds by the quantity timbre. It is also referred to as tone color or tone quality. So I think intensity, pitch and timbre are clear to you. Now look, loudness. Sound is a type of energy. Which sound do you think has the most energy? A loud sound or a quiet sound? The louder a sound is, the more energy it has. The quieter a sound is, the less energy it has. As you move away from the sound, the quieter the sound becomes. The more you move towards the sound source of the sound, the more loud it will be to you. So we can measure how loud a sound is using the decibel scale, that is in short form dB. The more energy you put into striking the hammer, the louder the sound. Dear students, now I will discuss about noise pollution. Dear student, sound is essential in our lives, but excessive sound makes our lives intolerable. Those who live in cities, especially those who live besides a road, observe that sound produced from different engines of the bus, car, truck, and of continuous horns goes beyond our tolerance limit very often. Most of the time, we are used to living in such type of pollution for a long time. If we are fortunate enough to go to a silent place where there is no sound pollution, then suddenly we can realize the importance of life without sound pollution. So here you are seeing an animated picture. Look, from different source sound pollution occurs, that from the horn of the bus, then from the picketer, then from the mic, from horn of the car, then from the music that is heard with loud sound. For this way, for different ways, sound pollution occurs in the environment, and that is intolerable. There are some other pictures that I will show you of sound pollution. Look, in a busy road, sound pollution occurs. Look, due to picketing in the election. Due to this, I think it is clear how sound pollution is occurring in the environment by seeing these pictures. So loudness in decibel from different source, intensity of sound of different types. Look, jet plane taking off 150, power motor 100 decibel, then pouring cat 25 decibel, so, and there is a chart in your book also. You must try to memorize that chart. I have collected this from Google, but you can also follow your book, and there you can find that jet engine produce the sound intensity of 110 to 140 decibel, then traffic 80 to 90 decibel, then car 60 to 80 decibel, television 50 to 60 decibel, conversation 40 to 60 decibel, breathing 10 decibel, sound of mosquito 0 decibel. That means that cannot be heard by us. So dear students, today this chapter is finished and I will declare the date of the test in the messenger page that you are following. So you must practice this chapter properly and you should practice more mathematical problem by following a test paper from the previous year. Because if you solve at first all the questions, those came into the SSC examination in different years, then the full chapter will be totally clear to you, and you must practice MCQ by reading each and every line very carefully and attentively. So everybody, thank you all for watching this content. Goodbye.